Hello, this is Britt Caswell with another example video. In this video, I'm covering example 2 from section 4-3 in the SavvasRealize Algebra 1 textbook. So the goal of this example is to understand equivalent systems of equations. So what that means by an equivalent system is when we change the system using multiplication. Okay, so I'm going to write that here so that we know what that means. So again, we are changing the system using multiplication. So when I have an equation, as long as I do the same thing on one side as I do to the other side, I will have an equivalent system. All right. So this section is all about solving using elimination, okay, or solving by adding. So our goal for this is to have an expression to where both of the x values or both of the y values have the same coefficient. Now, notice here that neither of them do. So we need to change either one or both of the equations so that the coefficient in front matches. So I'm going to go ahead and multiply this top equation. All right, and when I do this, I'm going to multiply both sides of the equation so that the equation itself doesn't change. Okay, remember you can't change that balance. So I want the x to have the same coefficient. So to make the 1 on the x match the 2, I'm going to multiply it by a 2. And I can either multiply it by a 2 and subtract both equations, or I can multiply it by a -2 and add both equations. Okay? So here's how the system changes. So this top equation, -2 times x is -2x. -2 times 3y is -6y. And -2 times 7 is -14. So that is my new top equation. Now here on the bottom equation hasn't changed at all. So I'm going to leave it just as it is. So now that we've done that, now we have our situation that's all set up so that we can add the two equations together and get our single variable. So when I add, the x's now eliminate each other. So -6y plus 2y is -4y. And -14 plus 6 is -8. So if I divide that -4 out, I get that y is equal to 2. So when I go to substitute that y equals 2, I can do it into either of the red equations, or I could substitute it into the black equation. It doesn't matter. I'm going to go ahead and substitute it into the original red equation just because it looks a little easier for me. So I have x plus 3 times y. And remember, when you substitute that 2 in for y, you have to use parentheses. So now 3 times 2 is 6, so this turns into x plus 6 equals 7. And if I subtract 6 from both sides, that leaves me with x equals 1. So our final solution, if I write it as an ordered pair, is the ordered pair 1, 2. Now remember, that means that's where the two lines are intersecting on the coordinate plane. Let's try another one. So again, we have a system here where our variables don't quite line up. Now, if I wanted to, I could eliminate the y's. Okay, I can multiply both of the equations by something so that the y's will match. But that's often too much work. When it comes to equivalent systems, I usually look for if one of the variables doesn't have a coefficient. So here, I'm going to be multiplying the top equation by a 2 to make it match x. Now I want to show you what I can do if I don't match my variables. Alright, say I don't want to deal with a negative number. So if I multiply this purple one, I'd get 2x plus 2 times 2 is 4, so 4y. And then 2 times 4 is 8. So there's our top equation. Our bottom equation looks just like this. Alright, so say I did my multiplication and I didn't feel comfortable multiplying by the negative. Okay? So if you have a situation like this, you could just subtract the two equations. Alright? You don't have to go through a bunch of work. You could just do subtraction instead. But it's important that you don't forget that you could subtract. Okay? So when you subtract, you have to do it to every single term. So 2x minus 2x, that's 0. So 4y minus negative 5y. 4 minus negative 5 is the same thing as adding. So that's a positive 9y. And then 8 minus negative 1 is 9. And then you could divide by 9 to get y equals 1. Alright, so subtracting works just as well as adding. It's just you have to make sure that you actually subtract every time. So I'm going to put that note here as well. So again, you can subtract instead of adding if your signs are the same. Alright, so now that we found y, we can go and solve for x. Alright, so I can use either the black equation or either the purple equations. I'm going to go ahead and use the original purple equation just because it looks easier. So I have x plus 2 times y. So my y was a 1 is equal to 4. So 2 times 1 is 2. And if I subtract that 2 from each side of the equation, I get that x is equal to 2. So my final solution here is the ordered pair 2, 1. Alright, so let's get wild and do just one more of them. Alright, so again, neither of our variables quite matches. So I could either multiply this top equation by 2, which is what I'll be doing, or I could multiply this bottom equation by 2 or negative 2 to match my x's. But I'm going to be working on matching my y's so that my y's cancel. So 2x times 2 is 4x. Y times 2 is 2y. And 2 times 2 is 4. So there's my equivalent expression there at the top. And that second equation is staying the same. I'm not changing it at all. So I have x minus 2y equals negative 5. So now I have a set of expressions where my coefficient in front of y is the same value but with opposite signs. So I'm going to add. My two y's will cancel out. So 4x plus x is 5x. And 4 plus negative 5 is negative 1. And then if I divide by 5 on each side, I get that x is negative 1/5. Now inherently that's not a bad thing, but it makes me a little paranoid to not get whole number answers. So I'm going to check myself when I'm done with this just to make sure that I didn't mess it up, okay? So now that I know what x is, now I need to go through and find y. Having that fraction is going to be really ugly. Alright, so I'm going to choose to plug in that negative 1/5. I'm going to do it into the original red equation. It doesn't matter which one you choose, just so long as you do it, okay? So 2 times negative 1/5 is negative 2/5. And since this is in fifths, I'm going to go ahead and convert this 2 right away. Okay, if I multiply 2 times 5/5, I get that common denominator of 5. So then I'm going to add 2/5 to each side, and I get y is equal to 12/5. So now, because I'm getting kind of weird numbers here, I don't have my clean whole numbers, I'm going to do a check step, and I'm going to make sure that I'm not making any mistakes. So where the x is, I'm going to use this bottom equation. Where x is, I'm going to plug in negative 1/5, and then minus 2, and where y is, I'm going to put in 12/5, and that's equal to negative 5, so that's that bottom equation. So this turns into negative 1/5 minus 2 times 12/5, that's going to be 24/5. So negative 1/5 minus 24/5 is negative 25/5. And if I reduce negative 25/5, I get negative 5. And does negative 5 equal negative 5? Yes. So this is my actual answer. Okay, so I would write it as the ordered pair. Negative 1/5, 12/5. But it's always important to check if you get kind of strange numbers like this to make sure you're not making any mistakes. Oh, my little touchpad stopped working. So there we have it. That is how we look at equivalent systems of equations. Until next time.